A bar magnet is placed at position X, close to one end of a coil, and on the axis of the coil is shown. The graph shows how the velocity of the magnet varies, so it stays constant going away, then changes direction, moves back from Y to X. The magnetic field of the bar magnet still affects the coil when the magnet is at position Y, which graph represents how the induced voltage in the coil changes as the magnet moves. So, if you know from Faraday's law, the EMF is minus the rate of change of the flux, where the flux is defined as the magnetic field times the area through which it passes. Or if you want to be really technical, if the magnetic field varied in that area, it would be B as a function of each position times the little area it takes, so dx and dy, and then integrated over the two. So this is B dot ds in vector calculus. Again, nothing to worry about here. It's just an NSAA on ENGAA. They're not expecting any more knowledge than the magnetic field should be roughly constant through the area it's passing. So looking here, magnetic field through that cross section of the coil will look like so. And then what's going to happen as we move the magnet away? Well, the flux, or the magnetic field, will decrease, because as we move further away, the magnetic field gets weaker. But how weak the magnetic field gets will get slower and slower over time. Because if you know, magnetic fields follow a 1 over r type decay or fall off. So the change in the magnetic field will still be negative, but it will get the change will get smaller and smaller each time. So that means as we move away at constant velocity, the actual change in the magnetic field would get more and more negligible. So what that means is it wouldn't be A, it wouldn't be C, and it definitely won't be F, as that's getting larger. But then, as we move the coil back from position Y to position X, the magnetic field will start increasing, and it will increase at an increasing rate. And so if you notice, because that's positive, the EMF will definitely have to be negative, because the rate of change of the flux will be positive. So the EMF is minus the negative value of this. So it could definitely not be E, and it can't be B. So the only logical answer is D. So if you notice, the induced voltage goes down, but by less and less each time, as the change in the flux will be getting more negligible. And then it changes direction as we move back from position Y to position X. If we were really far away to start with and we moved a little bit, the graph would actually look more like A, because the lines would be relatively flat, as the change in the EMF would be nearly negligible, and the induced voltage would also be pretty close to zero, but pretty flat in that region. So A could have been a possibility if we were really far away from that coil, or if it was just a very, very, very weak magnet. So again, just to put this a bit more in maths, if anyone is still confused, if we looked at the magnetic field at one time, let's say the magnetic field is B1 through that area, then when we move it away, the magnetic field is B2 through that area, then the change in flux would be B2A minus B1A. It's a change in flux. Now, what would the change in time be, or like how long would that have happened over? It would be the little distance the magnet moves, delta S, over the speed of the magnet there. So if we put this in, we get V. If I put that in, delta phi over delta t will be V over delta S times B2 minus B1 times A. It's delta phi delta t. Now V is a constant and A is a constant. And then let's say if we looked over the same bit of time, then delta S would also be a constant. But B2 minus B1 will get weaker and weaker, as in the B2 minus B1 difference will be smaller and smaller as we move further and further away. So if you notice, that means that delta phi over delta t will also get smaller and smaller, which means the EMF will get, which is minus delta phi delta t, that will get less and less positive because this is getting less and less negative. So that's why the EMF is positive to begin with, very highly positive, and then goes down, as shown in answer D. So if that's unclear, take some time to think about it. Hopefully it should start making sense. But you can also see that this equation, you'd end up getting V times A, and then this would be the change in B over change in, instead of S, I'll maybe use X, over equals delta phi by delta t. Compare this with chain rule. So that's essentially what we've done